Let's find the absolute maximum and minimum values of this function on the interval -2 to 2. As a reminder, finding the absolute maximum and minimum involves finding critical points and then taking those critical points that are in the interval, plugging those in along with the endpoints of the interval to find where our largest and smallest y values are. So to find critical points, we're going to take the derivative of this function, but it's probably beneficial first to rewrite the function instead of a square root as a 1/2 power. That can help us understand that we are going to start with the power rule. The power rule says that we multiply by 1/2, we subtract 1 from that power, and then the chain rule says we have to take the derivative of what is inside here. Let's simplify this derivative a little bit. The 2 and the 1/2 cancel. This 9 minus x squared to the negative 1/2 can go to the denominator. And now recall that critical points occur when the first derivative is 0 or undefined. So this first derivative is 0 if the numerator is 0. That just means x equals 0, so that's a critical point. And the first derivative is undefined when the denominator equals 0. That would mean 9 minus x squared equals 0. And you can simplify this to give you x is plus and minus 3. Notice though that x is plus and minus 3, they don't fall on the given interval, so we're going to get rid of those critical points. And we're just going to plug in x equals 0 and our endpoints into the original function. Plugging in x equals -2 looks like it's going to give you the same values if you plug in x equals +2. And to me that looks like the square root of 5. And if we plug in x equals 0, it looks like we're going to get just the square root of 9, which is 3. So we have an absolute maximum here, and we have two absolute minima here and here. What we say is the absolute maximum value of this function on the given interval is 3, and that occurs when x equals 0. And we have two absolute minima of this function. The value is the square root of 5, and that occurs at the endpoints of the interval -2 and 2.